This is lesson 8.1. We're going to talk about similar polygons. We've already talked about similarity with dilations, so now we're going to talk about similar polygons in general. So similar polygons are polygons with the same shape but a different size. So our polygons will be similar if they meet the same things our dilations did. The corresponding angles are congruent, and if the corresponding sides are proportional. So the ratio of the sides is still called the scale factor, and we're still going to do new over old. When we make a similarity statement, it's old is similar to new. So just a little note for this, it's still new over old, and our similarity statements are going to be written as old is similar to new. So here, what is the scale factor of ABC to DEF? So old is ABC, to DEF is the new one. So I'm going to pick a pair of sides that go together, like the 8 and the 12. So new over old would be 12 over 8, which reduces to 3 over 2. If I asked instead DEF to ABC, so now ABC is new, so it'd be 8 to 12, which is 2 to 3. And there was one more part we didn't fill in here, and that's about the polygons are similar, then their perimeters are also proportional. So if I ask for the ratio of the perimeter of DEF to ABC, that would be the same as the scale factor, so I would still say 2/3. For our similarity statements, you might notice I used a little symbol here, so that little symbol is our symbol for similar. So if I wanted to make a similarity statement for these two triangles, I could say triangle ABC is similar to, so now the A had one curve that matches with the D, the B had two curves that matches with the E, and the C had three curves that matches with the F. So our similarity statement can be written knowing what angles go together, but also if we have the similarity statement, we will know what angles go together, and that takes us to our first example. We're going to list all the congruent angles and write a proportion that relates the corresponding sides. I'm going to use my similarity statement to do this. The J is in the same place as the P, so angle J is congruent to angle P. The K is second, the M is second, so angle K is congruent to angle M. And the L is third and the N is third, so angle L is congruent to angle N. As for the sides, we know sides are made up of two letters. So JK are the first two letters that corresponds to PM. So this is a fraction, one triangle to the other, equals, now I'll go to the next letters, KL matched with MN, equals, now we'll go first last, JL matched with first last, PN. So this would be a proportion relating the corresponding sides. So there's a check in here for you to try. You can pause now. Answers are posted on Google Classroom. For example, 2a, we're given a similarity statement and we want to find the value of x. So I'm going to use this statement to know what sides match up, and I'm going to label them as such. So the first two letters were DE. I'm going to circle the number on DE. The first two letters were MN. I'm going to circle the number on MN. The last two letters were EF. I'm going to box. I'm going to do something different. I'm going to box this thing for EF, and then I'm going to box for the last two letters here, the NP. And then I'll use DF. I'll triangle them. And MP, I'll triangle them. If I want to make a proportion, I'm going to make a fraction using numbers or variables that had the same symbol. So I could pick 15 and put it over 18 because those were the corresponding sides, and set that equal to x over 30 or 20 over 24. We don't need to do all three. Oops, that should have been 20 over 24. We don't need to do all three fractions if there's only one variable to solve for. I could just stick with this right here and cross multiply and solve. I could have stuck with this right here and cross multiply and solve. The only thing that wouldn't have helped me is if I left out this middle fraction, right? 15 over 18 and 20 over 24. There's no variables to solve, so that wouldn't make sense. So let's solve the one that I started with here. So cross multiplying 18 times x would be 18x. Cross multiplying here, 15 times 30 would be 450. So now if I divide both sides by 18, we get x is 25. So for the next example, it's quadrilaterals. A, B, C, D to Q, R, S, T. I'm actually going to cheat a little bit. I'm going to say BC was the X. So I'll start there and I'll match BC with RS. And then I'll pick one other pair of sides. So let's say AB and QR. We won't bother labeling the rest because there's no other variables. I already have a 12 compared to 6 and an X compared to 4. That's enough to solve. So we have 6 times x is 6x, 12 times 4 is 48. When I divide both sides by 6, I get x is 8. So there's 2 check-ins for you to try. Here's the first one if you'd like to pause. Going on to the next one. This is the second one if you'd like to pause. Answers are posted on Google Classroom. We mentioned this earlier, but here, the perimeters of similar figures, if 2 polygons are similar, the ratio of their perimeters is equal to the ratios of their corresponding side lengths. That means it's equal to the scale factor. This allows us to find the perimeter of a shape without finding all of the sides of that shape. So for example, 3A, we're given that the triangles are similar with a scale factor of 5 to 3. We want to find the perimeter of triangle PQR. So from KLM to PQR, new to old. So the new shape was PQR, the old shape was KLM. So 3 to 5, 5 to 3, okay? So the first thing I did was establish what number went with what shape. The second thing I'll need to do is if I want the perimeter of this one, I need the perimeter of this one. So we're going to find the perimeter of triangle KLM. So P will equal 6 plus 12 plus 15. This perimeter would be, oops, I multiplied there, 33. So if I want the perimeter of PQR, I'm going to set up a proportion. I could take 3 over 5, so from one shape and another shape, and now I'll take the perimeter here to the perimeter here, 33 to P. So cross multiplying this, I'll have 3 times P equals 5 times 33, which is 165. Dividing both sides by 3, I get P is 55. So the hardest part here was knowing new to old, where PQR was new and KLM was old. And that's why I put the 3 and the 5 in those places. For example, 3B, this is a little simpler because they're not giving us the scale factor, we just have the sides that we can use. So the TE here matched with TR here, so the 25 matched with the 40, which means the perimeter here will match with the perimeter here, and I can find this one by adding 40, 54, and 22. So that perimeter was 116. So 25 to 40 will be P to 116. So cross multiplying here, 40 times P is 40P, and 25 times 116 is 2900. And when we divide both sides by 40, I get the perimeter is 72.5. It's okay to get decimals. That's fine. So here's an example for you to try. Pause if you'd like. Answers are posted on Google Classroom. So for example 4, a town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. They've drawn that out for us here. The new pool will be similar in shape to an Olympic pool, but will have a length of 40 meters. Find the perimeters of an Olympic pool and the new pool. So for our Olympic, we can easily find our perimeter here. We're going to add up all four sides. That means we're going to find 50 plus 50 because there's two 50s, plus 25 plus 25 because there's two sides that are 25. So that should be a perimeter of 150 meters for the Olympic pool. Our new pool will have a length of 40 meters. So they said the length was 50 before, and now the length is 40. So if the bottom here was 50, the bottom here will be 40. It doesn't matter what the other dimension is. We know if I compare one shape to the other, 50 to 40, I can compare one perimeter to the other, so 150 to P. So cross multiplying, we're going to have 50P equals 40 times 150, which is 6,000. So dividing by 50, this perimeter would be 120 meters. So there's one last check-in for you to do. You can pause here if you'd like, but this is the end of the lesson. Answer is posted on Google Classroom. That is section 8.1.